Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics from May June 2022, paper 2, variant 2. This is the latest paper and this is based on new syllabus. In this paper, you will see few changes. In the last year papers, you will see data on one page and formulae for AS and A2 physics on another page. But in this new syllabus and this year papers, you will see data and formulae only for AS physics on one page. So this is kind of subtle change in this paper from 2022. In today's class, we will discuss two main questions from mechanics, and these questions are from measurements, forces, work, and energy. So pause the video before you watch the solution. Do question first by yourself and then come back to video and check the solution and compare solution with my solution. This is the best way you can get the maximum benefit from these videos. You need to understand physics is not just for memorizing. You can never improve your concept of physics just by memorizing. What you need to do for physics is to improve your conceptual understanding, because every question in physics is different and it is only based on your conceptual understanding. It's like a tool. If you have tool but you don't know how to use that, you will never be a good technician. In physics, if you memorize concepts but you don't know how to use them, you can never be good at physics. So always try to understand concepts, not just try to memorize. Understanding is most important in physics. In today's class, we are talking about May June 2022 exam paper, and the total time for this paper is 1 hour and 15 minutes. You need to answer all questions on this paper, and total mark for this paper is 60. On second page of exam paper, you can find values of some constants, and these constants are very important. Maybe you will need some of them for some calculations in your exam. So if you need value of any constant, you can come to this page and you can find value of required constant, means the constant you need. At AS level and also at A2 level, you have to use G is equal to 9.81. You cannot use G is equal to 10. So very important point, you need to be very clear about this one. So you need to use G is equal to 9.81, not G is equal to 10 meters per second per second. This one was okay at IGCSE level, but at AS level, you have to use 9.81. On the second page of exam paper, you can also find some important formulae. 7 formulae are given to you for AS physics. So this one is 1, this is 2nd, 3rd, 4th, 5, 6, and 7. Means you have formulae about 7 different concepts. The first one is about accelerated motion. If acceleration is constant, means when acceleration is uniform. So these two formulae you can only use if A is constant. A is constant means that value of A is not changing with time, or simply you can understand value of A is just one value, and that value is not changing with time. And the second one is about hydrostatic pressure, and in this formula you need to understand rho. Rho is density of fluid. Very important. In some questions they will try to confuse with this density, so you need to understand this is density of fluid, not density of any solid object. And this delta H. Delta H is not height, this is the depth, means distance from the surface to the object. So this one is depth. Upthrust, this is a new formula. This was not in 2021. So in the formula list, you don't see this formula in 2021. So this one is the new one. So this is also given to you, formula for upthrust. In this formula, rho is, this is density of fluid. In this formula, rho is density of fluid. You need to understand what is V in this form. V is volume of fluid displaced. Volume of fluid. Fluid can be liquid, it can be gas. Volume of fluid displaced. At AS level, most of the time, this is volume of liquid displaced, but this also can be volume of gas displaced. So we say volume of fluid displaced. The second, this formula, this is about Doppler effect. You need to understand when to use plus, when to use minus. So for this formula, if the source is approaching, then you can calculate observed frequency. So we can write down F naught. That will be equal to V over, means the speed of the wave, over V minus Vs times frequency of the source. In this case, F observed has to be greater than frequency of the source. So that's the reason this denominator, this has to be smaller. So we have the minus sign. And if the source is moving away, so let me write down here, because clear understanding of these points is very important. When the source is moving away, observed frequency will be equal to speed of the wave in medium over speed of the wave minus speed of the source. But in this case, this has to be plus. The reason when the source is moving away, the reason is that observed frequency has to be smaller, means the observed frequency will be smaller than frequency of the source, means the frequency of the sound produced by source. And this is when the source is moving with constant speed. So then F naught is equal to V over V plus Vs. If the source is accelerating, situation will be different. That one we will discuss later. If we go to next question, this is called transport equation. Very important one in electricity topic. Transport equation. So this is transport equation. And these two formulae we can use for resistors. Resistors in series and resistors in parallel. So it's very important if you have clear understanding of these formulas. And rest of the formulae, you need to be able to derive them, or you need to remember them, and you need to practice them so you know how to use them as well. Here is question number 1. Before you answer this question, I want you to promise to yourself you will not memorize physics. You will try to understand physics. If you will develop this habit, then you will see physics is fun. You solve problems, you will be a problem solver, and you will be explorer of universe secrets. So if you really want to be a problem solver and you want to make the life of human being easier, or you need to serve human beings in any way, the best way, the only way is to understand the secrets of universe. Means try to understand the principles of universe. And physics is science that help you to explore secrets of universe. So study to understand, not to memorize. And if you have any questions, if you have any doubts, you can leave in comments and I will answer as soon as possible. And I will try to clear your doubts as much as possible. Let's do question number 1 now. For question number 1, part A, it is given to us in the following list, underline all units that are SI base units. So you need to understand there are 7 SI base units and 7 SI base quantities. SI means System International. So if you look at the first one, ampere, this is SI base unit because this one is unit of current and current is SI base quantity. Degrees Celsius, this is not SI base unit. Kelvin is SI base unit. So this is not SI base unit. Kilogram, this is SI base unit because this is unit of mass. So this is SI base unit. Newton, this is not SI base unit. This is unit of force. And force is not SI base quantity. So the answer for this question is simply you need to write on ampere. You need to underline. I mean you can draw the line here and you can draw the line here. If you draw these two lines, you will get 1 mark and that is the mark. For part B, it is given to us figure 1.1 shows a horizontal beam clamped at one end with a block attached to the other end. So in this case, simply you can see we have this block, it means we have this beam. So it is clamped at one end and the block is placed at the other end. It is given to us the block is made to oscillate vertically. So when we displace this block, this will oscillate up and down, vertically up and down. Young's modulus of the material of the beam is given. So this is how you can calculate Young's modulus. In this case, it is given to us m is the mass, t is the period of oscillations, and k is a constant. And table is also given to us. In this table, you can see we have quantity and the percentage uncertainties are given. The student uses the value of km and t to calculate value of E, and value of E is also given to us. We will need this value later. For part B1, we need to calculate the percentage uncertainty in the value of E. E is given to us. E is equal to km over t square. If you look at quantities, these quantities are multiplied and divided. So when quantities are multiplied and divided, then we have to add the percentage uncertainty. So in this case, we have this is delta E by E, percentage uncertainty. So we can write on percentage uncertainty in E. This one has to be equal to percentage uncertainty in K. So this is how you can write on percentage uncertainty in K and percentage uncertainty in M. Percentage uncertainty plus we have to multiply with 2 the percentage uncertainty of time period, because time period has power 2. So that's the reason we have to multiply this one by 2. Now simply we need to plug in values. We have percentage uncertainty in K, that is equal to 2.1%, and percentage uncertainty in M, that is equal to 0.6%, and percentage uncertainty in time is 1.5%. So this is 1.5%. So simply we can write down in our proper way. So this is 1.5%. Let me write down here. So this is 1.5%. If we add all of them, our final answer should be 5.7%. So the answer for this question is 5.7. So let me double check this one. Is it right or not? Let me use calculator. So simply you can see I have already calculated here. So this is equal to 5.7. So our final answer is correct. So 5.7 is the right answer. This question has 2 marks. The first mark you will get if you have written these percentages, means you have added them. You will get C mark, and the second mark you will get if you have got the right answer. So this is the second mark. If you have got the right answer, you will get 2 marks. But if your answer is wrong, you have written this step, you will get 1 mark. For the second part, we need to use our answer from D1 to determine the value of E with its absolute uncertainty to an appropriate number of significant figures. So very important one. So you need to take care of significant figures in this question. If you will not take care of significant figures, you will lose 1 mark. So let's try to understand how we can answer this question. In part B1, we have calculated delta E by E. The percentage uncertainty we have calculated, that one was equal to 5.7%. So this is the percentage uncertainty. Now we need to understand how we can convert percentage uncertainty into fractional uncertainty and vice versa. So let me write down here first of all fractional uncertainty and percentage uncertainty. So how we can convert fractional into percentage and percentage into fractional. Percentage uncertainty. So let me write down here. So we have percentage uncertainty. If you want to convert percentage uncertainty into fractional uncertainty, you have to divide by 100. So simply I will say you have to divide by 100. That if you want to convert fractional uncertainty into percentage uncertainty, you have to multiply by 100. Now in this case, we have percentage uncertainty, we want to convert this one into fractional uncertainty. So we have to divide this one by 100. So simply we will write down here 5.7 divided by 100. So this is what you need to write down. We need to calculate delta E. Delta E is absolute uncertainty. In order to calculate delta E, simply we can write down this is 5.7 divided by 100 times E. So we can write down E here. Value of E we have. So we can write down 5.7 divided by 100 multiplied by value of E. Value of E is given in question. So simply we can write down 8.245 times 10 to 9. Now, if we solve this one for delta E, means for absolute uncertainty of E, you will get 0.47 times 10 to 9. We need to understand at AS level, absolute uncertainty has to be written up to one decimal place only. So we can write down this one 0.5 times 10 to 9. So this is absolute uncertainty. So let me write down here. This one is absolute uncertainty. So simply this is absolute uncertainty of E. So this is absolute uncertainty. Now we can write down absolute uncertainty and we can write down Young's modulus. So the absolute uncertainty is 0.5. Now you need to understand. So let me rewrite one point here. This one has to be up to 1 dp only. So this is the point you need to understand. This is the main point you need to understand. Now this is given to you up to 3 decimal places. Now we need to understand absolute uncertainty and the measurement. They must have same number of decimal places. So we can write down this is 8.2. So these two quantities mean absolute uncertainty and measurement. They should have same dp. So they should have same dp's. That's all. So if you write down your answer like this, you will get 2 marks. 1 mark you will get if you have calculated delta E. So this one is C mark. And the second mark is answer mark. If you have written answer in this form, you will get the second mark. But if your answer is right, you will get 2 marks. But if your answer is wrong, you have written this step, you will get 1 mark. So always write down steps. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics from May June 2022, paper 2, variant 2. Today's class, we will start from question number 2. In the last lesson, we have discussed question 1 on measurements. So for the solution of that question, you can go to mechanics part 01. Today's class, we will start from question number 2 and we will discuss questions on kinematics, forces, energy and power in today's class. Let's study together. Let's improve together. Before we start working on question number 2, I just want to highlight some points about writing measurements with absolute uncertainties. For this question, we have already discussed that the value of E is equal to this. And delta E means the absolute uncertainty. In E, we have also calculated that was equal to 0.47 times 10 to 9. Now, in this case, you can see we have value of E that is equal to 8.245 times 10 to 9, and delta E is also given to us. Now we need to use appropriate number of significant figures and we need to write down our answer. So in order to write answer for this question, we need to consider first of all number of SF in absolute uncertainty. Absolute uncertainty, you have to write down up to 1 SF. I mean, you need to round this one up to 1 SF, one significant figure. So if we round this one up to 1 SF, simply we can write down this will be equal to, because 7 is greater than 5, so we can write down 0.5 times 10 to 9. Now absolute uncertainty has 1 SF, so we can write down absolute uncertainty here. So this is 0.5. Now we need to consider how many decimal places absolute uncertainty has. Absolute uncertainty has only 1 dp. So this measurement also must have 1 dp. So simply we can write down this one up to 1 dp. This will be 8.2 times 10 to 9. So we can write on here 8.2. Now step 1, the first point you need to understand is absolute uncertainty has to be rounded to 1 SF. And the second thing you need to understand, absolute uncertainty and measurement, they should have same dp. So this is the point you need to understand. For question number 2, it is given to us a sphere is attached by a metal wire to the horizontal surface at the bottom of a river, as shown in figure 2.1. The sphere is fully submerged and in equilibrium, with the wire at an angle of 68 degrees to the horizontal surface. The weight of the sphere is 32 newtons. Upthrust acting on the sphere is 280 newtons. Density of the water is given. For this question, we can also assume that the force on the sphere due to the water flow is in horizontal direction only. Let's move on to second part. If you look at the second slide, you can see question is asking us for part A, we need to consider the components of the force in the vertical direction and we need to determine the tension in the wire. So this is the hint. Question is telling us we need to consider vertical direction. So it means you have to resolve forces in vertical direction. So this is kind of hint given to you. If you see any hint given in the question, follow that and that will make your life easier. Now let's try to understand first of all forces acting on the sphere. One thing we need to understand, if you look at the sphere has a mass, so the weight of this sphere has to be acting downwards. So simply we can say W is acting downwards and the magnitude of W is given, that is equal to 32 newtons. Upthrust is also given. Upthrust is acting on the sphere, so we can draw upthrust is acting up and the value of upthrust is given, that is equal to 280 newtons. Now we need to find out direction of tension. Now if you look at this ball, imagine that we cut this string. If we cut this string, horizontal force is also acting on the sphere and that is acting to the right. So this sphere will go this way. Now, if you look at this sphere is at rest. It simply means that tension is acting downward. So simply we can draw direction of tension. So this is a tricky part. Maybe some student, they will draw direction of tension in wrong direction. So now you can see these are the forces acting on this sphere. There is also force acting on this sphere that is due to water flow. So we can simply say this force is F. But magnitude of force due to water flow is not given, so we no need to worry about that. We can answer this question by resolving forces along vertical form. Now we need to understand tension has two components, so we can resolve this one into two components. So if I draw triangle here, so you can look at this triangle. If you look at this triangle, these are horizontal and vertical components of tension. So you can see one component of tension is acting to the left and this one has to be equal to F. And one component is acting down. If this angle is 68, this one will be 90 minus 68 and this angle, this will be equal to 68 degrees. Now this component of tension, this will be T sine of 68 degrees and this one will be T cosine of 68 degrees. Now if we take this sphere, I will redraw this one here and I will only draw forces acting on this sphere in vertical direction. So I will write on here vertical direction only, along vertical direction. If you look at this sphere and we draw the forces acting on this one in vertical direction only, you will see there are only three forces acting on this sphere. One force is acting up and this force is upthrust, and magnitude of this one is equal to 280 newtons. Weight of this sphere is acting down, that is W, and magnitude of this one is 32 newtons. There is component of tension that is also acting down, and that component of tension is equal to T sine of 60. T sine of 60. So simply we can write down T sine of 68 degrees. Sphere is not moving along vertical, not moving up and down. It simply means that T sine of 68 degrees plus W, this one is equal to upthrust, or simply you can say downward forces in this case are equal to upward forces. T sine of 68, so again we can write down T sine of 68 degrees, W is equal to 32 and U is equal to 280. We need to find out value of T. So simply we can write down this is 280 minus 32 divided by sine of 68 degrees. If we solve this one, value of T will be equal to 270 newtons. And this is value of T, and this is our final answer. This is what question was asking us to calculate. This question has 2 marks. You will get first mark, that is C mark, if you have written this. And the second mark is answer mark. If you have got the right answer, you will get the second mark. So this is how you can approach this problem. For part D, we need to calculate volume of sphere, and we also need to calculate density of sphere. But for this question, it is given to us upthrust acting on the sphere is equal to 280 newtons. Weight of the sphere is given, that is equal to 32 newtons. And density of the liquid is also given, that is equal to 1.0 times 10 to 3 kgs. We need to calculate volume. Upthrust is given to us, so simply we can say upthrust, this will be equal to density of fluid times volume of fluid displaced times G. We need to calculate volume of sphere, but in this case sphere is fully submerged, so we can write down here, in this case sphere is fully submerged in liquid. Is fully submerged, it simply means that volume of fluid displaced Ft, this is equal to volume of sphere. So this is very important point, you need to be clear about this one. So in this case, this is volume of fluid displaced, but this is also equal to volume of sphere, and we need to calculate this volume. So simply we can say, in this case, volume of sphere, this is equal to upthrust divided by density of fluid times G. Now simply we need to plug in values. If we plug in values, we can find out value of volume. Upthrust is given, that is equal to 280. Density is 1000 kgs per kilogram, and G you have to use 9.81. If we solve this one, we will get volume is equal to 0.029 cubic meters. So this is our final answer up to 2SF. So this is answer for part B1. And this question has only 1 mark. If your answer is right, you will get 1 mark. Now we need to calculate density, but we understand mass is equal to density times volume. We need to find out density. So it means density will be equal to mass of sphere divided by volume of sphere. So this is volume of sphere. For this question, we have weight of sphere. Weight of the sphere is given, that is equal to 32 newtons. So mass is equal to 32 divided by 9.81. So this is the mass. Weight divided by G. And we need to divide by volume of sphere. If we simply plug in these numbers into calculator, our final answer will be equal to 110 kgs per cubic meter. And this is the final answer. So we can write down here 110 up to 2SF. This question has 2 marks. You will get first mark if you have written this step. Means you have entered value of mass and volume. And the second mark is answer mark. If you have got the right answer, you will get 2 marks. For part C, it is given to us the center of the sphere is initially at a height of 6.2 meters above the horizontal surface. The speed of the water then increases, causing the sphere to move to a different position. this movement of the sphere causes its gravitational potential energy to decrease by 77 joules. So you need to understand decrease by. So it decreases by 77 joules. Not decreases to, decreases by. So very important point. We need to calculate final height of the center of the sphere above the horizontal surface. So first of all, sphere is here, and in this case, height of the sphere is given. So simply we can draw from the center of the sphere. So this is the initial height. We can label this height as h1. So this is the initial height of the sphere. And then its gravitational potential energy decreases. It simply means that height of this sphere decreases. So we can imagine sphere is at this position now. And for this one, we can also draw the line. So you can imagine sphere is here. Let me redraw this one so you can see better picture of this. So we can draw the line from the center to this point. So the sphere is at this point now. And the height of this one, we can also draw the line. So this is new height. And we can say this height is h2. We can also label the difference in heights. So this is the difference in height. So this is the decrease in height. We can label this one by delta h. First of all, we need to calculate delta H. So we can write down the change in GPE. This will be equal to mg delta H, the change in height. We need to calculate change in height. So this will be equal to change in GPE divided by mg. Potential energy decreases. So we will be using negative sign here. It decreases by 77 joules. So we are using negative sign here. And we have to divide this one by weight of the sphere. That is equal to 32. Now if we solve this one, our answer will be negative 2.4 meters. Means the decrease in height is equal to 2.4 meters. We need to calculate final height. Means we need to calculate h2. Now we have calculated h2 minus h1. And this one is equal to negative 2.4. We need to calculate h2. So h2 simply we can say that will be equal to negative 2.4 plus h1. h1 was given to us, and that is equal to 6.2 meters. This one is equal to 6.2 meters. So we can plug in value of h1, that is 6.2. So the final answer will be 3.8 meters. So the second height, or simply you can say the final height of sphere is 3.8 meters from horizontal. And this is our final answer. This question has 3 marks. The first mark you will get if you have written this formula. So if you have written the formula, you will get 1 C mark. And the second mark you will get if you have got right value of decrease in height. And the final mark is answer mark. This is answer mark. Part D, it is given to us the extension of the wire increases when the sphere changes position as described in C. The wire obey Hooke's law. Very important point. Wire obey Hooke's law. Extension of the wire increases. State a symbol equation that gives the relationship between the tension in the wire and its extension. Identify any symbols that you choose. Now in this case, we need to understand this is the wire. So when this wire extends, it simply means that tension in this wire increases, and this wire obey Hooke's law. As this wire obey Hooke's law, it simply means that tension is directly proportional to X. Now simply we can say T is equal to Kx. So simply you have to write down T is equal to Kx. Then the symbol we have used is K. So you can say K is a constant. So that's all what you need to write down. This wire obey Hooke's law. So simply you can imagine that this one is the wire. As tension in this wire increase, extension of this wire will increase. But this wire obey Hooke's law. So tension and extension, they are proportional to each other. So simply you have to write down T is equal to Kx. And this question has only 1 mark. If you have written T is equal to Kx and you have written K is constant, you will get 1 mark. Very simple question, very straightforward one. For the second part, it is given to us before the sphere changed position, the initial elastic potential energy of the wire was 0.65. The change in position of the sphere causes extension of the wire to double. We need to find out the final elastic tension energy of the wire. So first of all, let's write down what is given to us. For this question, it is given to us initial elastic potential energy, EPE. We will simply write down EI. This one is equal to 0.65. Initial extension, we can say XI, that is equal to X. So imagine that is simply equal to X. It is also given to us that E final, this is what we need to calculate, but it is given to us X final means the final extension. This is equal to 2 times of initial. So we can say this one is equal to 2x. Now we need to understand elastic potential energy. How we can calculate EPE, elastic potential energy. EPE is equal to 1/2 K times X squared. If we rearrange this one, EPE, we can say this is equal to E, and if we divide this one by X squared, we also need to divide this one by X squared. So simply we will get here that will be equal to K by 2, and K is spring constant, and this is same for the same wire. So we are talking about the same wire, so we can say this is simply equal to constant, is equal to K by 2. So simply we can say this is constant. Now we need to understand we have EI, the ratio between EI, it simply means that over XI squared, this one has to be equal to E final over X final squared. We need to calculate EF, so we can rearrange. So final elastic tension energy, this one will be equal to initial elastic potential energy times X final square divided by X initial square. Now simply we need to plug in values. EI is given, that is equal to 0.65. X final, this is equal to 2x, and here we have only X squared. Now we need to simplify. So in this case we have 0.65 times 4x square divided by X square. So X square we can cancel with X square. We left with 0.65 times 4, and this is equal to 2.6 joules, and this is our final answer. This is one way you can approach this problem, but you can also approach in different ways. So this is the simplest way to approach this problem. One way to find the answer for this question is simply you can understand if X is double, it means this energy is 4 times. So the final energy has to be 4 times of initial energy. So E final has to be equal to 4 times of E initial, because extension is double, but the square of that is 4. So the E final has to be equal to 4 times of E initial. Why this is 4 times? Because energy is proportional to X squared. So if this is double, this has to be 4 times. So that is the main concept. This question has 2 marks. The first mark you will get if you have used this formula. So you will get first mark if you have used this one. So this mark will be C1, and you will get final mark, that is answer mark, if you have got the right answer. So this is how marks will be awarded for this question. For third question, it is given to us a man standing on a wall throws a small ball vertically upwards with a velocity of 5.6 meters per second. The ball leaves his hand when it is at a height of 3.1 meters above the ground, as shown in figure 3.1. Assume that A resistance is negligible. For part A, we need to find out the ball reaches the maximum height above the ground is 4.7 meters. We need to find out maximum height. In order to find maximum height, we need to consider initial height of the ball as well. So the maximum height will be equal to initial height initial height plus displacement. So we can say plus vertical displacement, or simply we can say displacement. This is how we can calculate maximum height. Initial height is given to us, that is equal to 3.1 meters. Now simply we need to find out its displacement. Let's try to understand motion of this ball. This ball has initial velocity and direction of initial velocity is vertically upwards. This ball will go vertically up, but force of gravity is acting down, so this ball will slow down. Finally, this ball will reach its maximum height, and at maximum height v will be equal to 0, means the final velocity of the ball at maximum height will be equal to 0. We need to find value of vertical displacement. In order to find vertical displacement, we need to use kinematic equations, because ball is moving vertically upwards and the force acting on this ball is only gravity, so acceleration of the ball is constant, so simply we can use kinematic equations. Let's try to use equations and try to find out displacement of this ball. Let's say the displacement of the ball is s, and we need to find out value of s. Initial velocity of the ball is given, that is equal to 5.6 meters per second, and direction of initial velocity is vertically upwards. We have value of v, the final velocity, that is equal to 0 at maximum height, and also we have value of a, that is equal to 9.81, and this is acceleration due to gravity. As gravity is acting down, so acceleration is also downwards, means direction of acceleration is downwards. We need to find s, so simply we can use kinematic equations now. In this case, we can use 2as, that is equal to v square minus u square. We need to find s, so simply we can rearrange this. We can say s is equal to v square minus u square divided by 2a. Now we need to take direction. One direction we have to take positive. So in this case, we will take up is positive, because direction of initial velocity is positive and displacement is also up. So if you take up positive, your answer will be positive. If you will take down positive, your answer will be negative. So in this case, we will take up is positive. So if we take up is positive, it means that initial velocity is positive, but acceleration is negative because it is in opposite direction. Now simply we need to plug in values. So this is 0 square and u is equal to 5.6 divided by 2 times negative 9.81. Now if we solve this one, we can find out value of s, and value of s in this case will be equal to 1.6 meters, and this is vertical displacement, and this is positive, it means displacement is vertically upwards. Now simply we have to write down this value here, 1.6. so the final answer in this case will be 4.7 meters, and this is the final answer. This question has 2 marks. The first mark you will get if you have used this formula. If you have used this formula, you will get 1 mark, and that is C mark. If you have used this formula, you will get 1 mark. And the second mark is the answer mark. If you have got this answer right, you will get the second mark. So this is how marks will be awarded. For part B, we need to calculate the time taken for the ball to fall from its maximum height to the ground. So very important point, you need to understand what you need to calculate. For this question, simply we need to calculate time taken for the ball to fall from this maximum height to the ground. And maximum height we have already calculated in part A. Maximum height in part A we have calculated, and value of maximum height was equal to 4.7. So this is value of at max. At this point, at maximum height, we have also discussed that the speed at maximum height is equal to 0. So now this is our initial velocity. So the initial velocity in this case is equal to 0. We need to find out the time taken for the ball to reach from this point to this point. And in this case, we need to understand only force acting on the ball is gravity. So it means acceleration of this ball is equal to g. So simply you can write down this is 9.81 meters per second and direction of acceleration is down. As the ball is falling, is moving downwards, so in this case we will take downward as positive. In downward direction we will take positive. U is equal to 0. We need to find out time taken. In order to calculate time taken, simply we can use S is equal to ut plus 1 half at squared. As u is equal to 0, it simply means that this is equal to 0. It simply means that S is equal to 1 half at squared. S is equal to h max, means this is the vertical displacement. Now we need to find out value of t. So we can rearrange this one. We can write down t squared. This will be equal to 2s divided by a, or we can say that t will be equal to 2s divided by a root of this. Value of S is equal to 4.7 meters and A is equal to 9.81. And this is positive because we are taking downward direction as positive. So this value is positive. Now if we solve this one, our final answer will be 0.98 seconds. So the answer for this question is 0.98 seconds. So this is our final answer. This question has 2 marks. The 1 mark you will get if you have used this formula, or simply we can say if you have plug in values in this formula, you will get 1 mark, and that is C mark. And the second mark is answer mark. If you have got the right answer, you will get second mark. So this is how you can calculate. For part C, it is given to us the ball leaves the man's hand at time t is equal to 0 and hits the ground at time t is equal to capital T. So at this point, value of t is given, that is equal to 0. And when the ball hits the ground, value of t is equal to capital T. For this question on figure 3.2, we need to sketch a graph to show the variation of the velocity of the ball with time t from t is equal to 0 to t is equal to capital T. Numerical values of v and t are not required. Assume that v is positive in upward direction. So this is very important. Now we need to understand when this ball will go up. So I will redraw here. So you need to understand what is happening. So ball will go up like this and then ball will come down. So this is how ball will move. Now if you look at motion of this ball, when the ball is moving up, acceleration due to gravity means that g is pointing downwards. So the ball will slow down in this region. So we can say from point, let's say this is point A and this one is point B and this is point C and let's say this is point D. If you look at A and B, between A and B, ball will slow down. So its speed will decrease. So we can say between A and B, ball will slow down. And at B, speed of the ball will be equal to 0. And then between B and C, we can write down between B and C, ball will speed up. So we can say ball will speed up. Its velocity will increase. Now we need to understand when the ball is moving up. We have taken, in the question it is given to us that upward direction is positive. So it means when the ball is moving up, V is positive. So we will take V here is positive, V here is 0 and V here when the ball is moving down. And so V is negative. So V is negative. At point C, we can write down at point C, value of the velocity means the magnitude of the velocity VC, this will be equal to VA. So at this point, velocity is vertically upwards, but when the ball is here, velocity will be downward, but the magnitude of velocity will be the same because it is the same height. But when the ball will go down, the speed of the ball will keep on increasing due to force of gravity. So we can say between C and D. So I will be writing here between C and D at this point. Between C and D, speed of the ball is increasing, but this is negative. When the ball will reach at D, we can write down speed of the ball at D. This will be greater than speed of the ball at A. But velocity of the ball at D is negative and at A is positive. So we can say VD is negative, but it is greater in magnitude than VA. And VA, we can say this one is positive. Now simply we need to sketch this one. And also we need to understand acceleration of the ball is always negative and downward. So we can say the gradient of the graph has to be constant. Gradient has to be constant. It must have only one value, and gradient has to be negative because gradient is equal to acceleration, and acceleration is vertically downwards, and we have taken up is positive. So the gradient of the line has to be negative. And velocity VA at this point, we can write down VA. Let's say we have velocity VA at this point, and here let's say we have VD. So VD has to be greater in magnitude than VA. So that's the reason you can see VD is greater than VA. Now simply we need to connect these 2 points. Means we need to draw a line. So let me draw a line. You need to simply draw the line. So we have initial velocity here and this is the final. It just need to be a sketch. So this is how you can draw the line. That's all what you need to do for this question. This question has 3 marks. 1 mark you will get, first mark you will get if you have shown that VA is less than VD in magnitude. And the second mark you will get if the slope of this one is constant. Gradient is constant and negative. Gradient is constant and negative. You will get second mark. Gradient is constant and negative. Means gradient has only one value. You also need to show in your sketch that VA means the initial velocity is positive and the final velocity VD, this is negative. So if you follow these 3 points, you will get 3 marks. So this is how marks will be awarded. I hope this part is clear to you. For part D, we need to state what is represented by the gradient of the graph in C. So simply you need to write down what is gradient of VT graph, and gradient of VT graph is equal to acceleration. So simply you can say gradient is equal to acceleration of the ball. If you simply write down acceleration, that is quite enough. But in this case, acceleration of the ball is equal to acceleration due to gravity, because in this case there is no air resistance. So simply if you write down acceleration, you will get 1 mark, and this is B mark. For part E, it is given to us a person throw a second ball with the same velocity and from the same height as the first ball. The mass of the second ball is greater than the mass of the first ball. Assume that air resistance is still negligible. For the first and the second ball, we need to compare magnitude of accelerations, and also we need to compare the speeds when they hit the ground. So first of all, let's try to understand if we change the mass, what is effect on acceleration. Let's say we have one ball that has mass small m, so we can imagine this is first ball. We can take an other ball, let's say the mass of the other ball is capital M. If we look at force of gravity, it means the weight of this ball. Simply we can say weight of this ball will be equal to mg, and only force acting on this ball is mg. So we can say the net force on this ball is equal to mg, and net force is equal to ma, so this is equal to mg. So mm cancel, so a is equal to g. Now if you look at second ball, now we need to understand if there is no air resistance, there is only one force that is acting on this ball, and that is force due to gravity, and that is equal to weight. So we can say weight, and weight of this second ball will be equal to capital mg. So the net force on the second ball is equal to capital mg, and the net force also is equal to ma, so we can say this is equal to mg. So mm cancel, so it simply means that acceleration due to gravity is independent of mass. So you need to be very clear about this point. So from here simply we can say here A is also equal to G. So acceleration due to gravity is independent of mass if there is no A resistance. So for the first case simply we can say acceleration will be the same, or simply you can say they have equal magnitude of acceleration. Next we need to consider the speeds. Now let's take first ball, this ball here, we will take the small ball and then we will take the heavier ball. So this ball initial velocity is u, and u is equal to 5.6 meters per second. So we can simply say u. This ball will go up and this ball will come down and it will hit the ground at this point. If you look at final speed of this ball, means the v, we can say 2as. This is equal to v square minus u square. So the v square in this case will be equal to 2as plus u square. So this is the equation for the first ball. Now let's take the second ball. So this is the heavier ball. We throw this one up, this will go up, and finally this will hit the ground. So it will hit ground at this point. For this ball, we need to understand A is the same, height is the same, initial speed of this ball. We throw this one up with the same initial velocity. So the U for this one is also equal to 5.6, or it can be any number. So I'm just writing what was given to us. So its initial speed is equal to 5.6 meters per second. So we can also calculate its final speed. So final speed of this one also will be equal to 2as plus u square. Now we need to understand for both balls, we can write down for these two balls, we can say for both balls, A is the same. A is equal to G. And the initial velocity is also the same. So we can say u is equal to 5.6 meters per second. And the height is also the same. So we can say the height means we throw them from the same height. So h is equal to s. So this is also the same. So it means they have the same speed. So if A is the same, S is the same, U is the same, it means V is also same. So it means that both balls, when they hit the ground, they will hit the ground with the same speed. So they will hit the ground with the same speed as well. So or simply you can say in this case, the final speed is also independent of their masses. So mass is not playing any role in this case. This question has only one mark, and that is B mark. If you have written this point, you will get 1 mark, and this also has B mark. If you have written same or equal, you will get this mark. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics and waves from May June 2022, paper 2, variant 2. In this lesson, we will talk about conservation of momentum, Young's double slit experiment, and some very important points about waves by solving past paper questions. Let's study together. Let's improve together. For question number 4, part A, we need to state the principle of conservation of momentum. Imagine that we have two balls. In order to understand principle of conservation of momentum, imagine that we have two balls. We have one ball A and another ball B. Let's say speed of this ball A is UA and this is moving to the right, and the speed of ball B is UB and this is also moving to the right. In this case, we are assuming that speed of UA is greater than UB. If UA is greater than UB, so at one point, means after a certain period of time, these two balls, they will collide with each other. One is moving like this, other is faster, so they will collide with each other. So when these two balls, they will collide with each other, they will exert internal forces on each other. So we can say this is ball A and this is ball B. So here these two balls collide with each other. So there will be force on ball A. This will be to the left. So we can say this is force on ball A. And there will be force on ball B. These two forces, they will be equal in magnitude. But you need to understand these two forces, these are internal forces. These are internal forces. These are internal forces because in this case we are assuming our system, and this is our system, and our system consists of only these two balls. If there is no net external force acting on our system, momentum of system before collision is always equal to momentum of system after collision if there is no net external force acting on this system. Net external force means that there is no friction, there is no air resistance, or there is no force by any other external agent. Then momentum of the system always remains constant. Then after this collision, we will see this is ball A. This will be continue moving this way, or this will bounce back. That is a different situation, but we are simply assuming they will continue moving in the same direction. So this is ball B. Then this ball B will have speed VB. It will go this way. So the momentum before collision, we can say P before in this case, will be equal to P after. P after. So we can write down in this case P before means the sum of momentum before collision will be equal to sum of momentum after collision if no net external force acting on the system. And this is principle of conservation of momentum. If no net external force acting on the system. So this is how we can define principle of conservation of momentum. Let me show you how you can write down a proper answer. So this is how you can write down the answer. In your answer, if you have mentioned total momentum before is equal to total momentum after, you will get 1 mark, and this is M mark, mean it has to be in your answer. And the second mark is A mark if you have mentioned no external force acts on the system, you will get A mark. So this is how these 2 marks will be awarded. First mark is M mark, it must be in your answer. If you haven't written this one, you will get no mark. And also it doesn't make any sense. If you simply say no net external force, that is not principle of conservation of momentum. So the first mark is M mark and the second mark is A mark, mean answer mark. For part B, it is given to us 2 balls X and Y move along horizontal frictionless surface as shown from above in figure 4.1. As you can see in this figure, we have ball X and the mass of ball X is 3 kgs and velocity of ball X is 4 meters per second in a direction at an angle theta to the line AB. And ball Y has a mass of 2.5 kgs and a velocity of 4.8 meters per second in direction at an angle theta to the line AB. The balls collide and stick together. After colliding, the balls have a velocity of 3.7 meters per second along the line on the horizontal surface, as shown in figure 4.2. For part B1, we need to consider components of the momenta along the line AB, and we need to calculate value of theta. So very important point. So this is the hint is given. You have to consider components of momenta along the line AB. So this is hint, and also you have to follow this hint to answer this question. And it will make your life easier. This is the way how you can answer this question in a simpler way. Let's try to understand how we can answer this one. We need to consider component of momenta along the line AB. First of all, let's try to understand how we can use conservation of momentum in 2 dimensions. It simply means that in 2D. In order to use principle of conservation of momentum in 2 dimensions, we need to follow the same rules as we do in projectile motion. It means we will treat horizontal motion separate and we treat vertical motion separate. In this case, we will treat momentum along X separate and momentum along Y separately. That's the main principle. So let me write down what I said. I simply means that momentum along X means sum of momenta along X before has to be equal to sum of momenta along X after collision. So this is the main principle. Along Y, you also need to do the same. Sum of momenta along Y before collision has to be equal to sum of momenta along Y after collision. So this is the main principle you have to follow, and this is very similar to projectile motion. So in this case, you have to treat momentum along x separately and along y separately. So it just becomes momentum in one dimension. So let's try to understand how we can use this principle. If you look at ball x, you can see it has two components of momentum. It has one component along line AB and one component perpendicular to line AB. And this component is along line AB. We have to consider this component to calculate value of theta. In this case, theta is given, mass of x is given, and velocity of x is given. So simply we can write down momentum of x before collision. This one will be equal to mass of x times speed of x times cosine of theta. Simply you can say ux. So I have written cosine of theta. So let me clear this cosine theta and I will be writing again. In this case, ux means that the component of velocity along AB. So we can simply say this is m mass of x times speed of u times cosine of theta. Means u is the speed of x. Now simply we need to plug in these values. Mass of x is 3 kgs and speed is 4 and cosine of theta. We can write down simply this is equal to 12 cosine of theta. So this is sum of momenta before collision. So we can write down momentum before, and this one has to be equal to sum of momenta along x after. So here is after. We will use this principle. Now we need to look at momentum of ball y. If you look at momentum of ball y, it also has two components. One component is vertically up and one component is along the line, and this is to the right. So we can write down momentum of ball y. And momentum of ball y, this will be equal to mass of ball y times velocity of y along x, means this velocity along x. So we can say with respect to this angle, that will be uy cosine of theta, means the velocity of y, simply means that velocity of y. Now in this case, we can say mass of y, that is equal to 2.5 and the velocity of y is 4.8 cosine of theta. So this is momentum before. So simply we can write down here now. We have 12 cosine of theta plus we have 2.5 times we have 4.8 cosine of theta, and this is equal to, after collision, momentum is only along AB. So these two balls stick together. It is given to us these two balls stick together. In the question this is given. So we have to take mass of these two balls. So simply we will say in this case this will be mass of x plus mass of y times the speed after collision. So this is vxy. So we can simplify this. So this is 12 cosine of theta, and we can also multiply this one. Simply you need to put these values into your calculator and you will find the answer. So this is cosine of theta. And mx, so we have mass of x and we have mass of y, and the speed is also given, that is 3.7. Momentum is a vector quantity, so you have to take one direction as positive. So in this case we are taking to the right as positive, so that's the reason these quantities are positive. Now in this case simply we need to calculate value of cosine theta. So in this case you can take common from here, so we can say this will be 12 if I take cosine theta common. So here we will have 12 times 4.8. So here we will have cosine of theta. So this will be equal to 5.5 times 3.7. So we need to calculate angle. So the theta will be equal to cosine inverse of, we will have 5.5 times 3.7, and this one will be divided by 12 plus we will have 2.5 times 4.8. So if we simplify this one, value of theta in this case will be equal to 32 degrees. So this is how how you can calculate this answer. So this is the answer for this question. And this question has 3 marks. The first mark you will get if you have written any one of them, means the momentum of x or momentum of y. If you have written along AB, you will get 1 mark, and that is the C mark. And the second mark you will get if you have written this step. So you will get second C mark. So this is second C mark. Then the last mark is answer mark. If you have got the right answer, you will get this mark. Now I just want to highlight a little bit. I just want to talk about a little bit about this point. So maybe this will little bit confuse you. So let me rewrite this. So let me rewrite this again. Momentum of x along AB. So you have to take mass of x along AB, and you need to take the velocity of x along AB, and that is equal to velocity of x times cosine of theta. So these two are similar now, so maybe it is more clear now. So this is how you can answer. For the second part, by calculations of kinetic energies, we need to state and explain whether the collision of the balls is inelastic or perfectly elastic. So first thing what we need to do is we need to calculate kinetic energies. So we need to follow given instructions. So we have to calculate kinetic energy. First of all, let's try to calculate initial kinetic energy, or simply you can say kinetic energy before collision. So we will write down kinetic energy before collision. Before collision, you can simply draw this line here. So this is what is happening before, and this is what is happening after collision. Now before, we have two balls x and y, and they have separate speeds. So we have to calculate kinetic energy of A, means kinetic energy of x, plus we need to calculate kinetic energy of y. If we calculate kinetic energy of x, we have to write on 1/2 mx ux square, plus we need to calculate kinetic energy of y, so that will be m uy square. Now simply we need to plug in values. So we have 1/2, mass is given to us, speed is given to us, and for the y we have the mass that is equal to 2.5 and the speed is equal to 4.8 square. Now if we solve this one, our answer in this case will be equal to 53 joules. So this is kinetic energy before collision. Now we need to calculate kinetic energy after collision. So simply we will write down kinetic energy after. And after we have these two balls, they stick together and they have the same speed. So we can simply write down 1/2 mass of x plus mass of y times v square. So we can write on 1/2 mass of x is 3 kgs and mass of y is 2.5 kgs and the speed is 3.7 square. And if we solve this one, our answer will be equal to 38 joules. Now we need to decide, is it elastic collision or is it inelastic? Let's try to understand conditions for perfectly elastic collision. Perfectly elastic collision. Perfectly elastic. Perfectly elastic collision. Collision is perfectly elastic if kinetic energy before collision is equal to kinetic energy after. So we can also say sum of kinetic energies before collision if it is equal to sum of kinetic energies after collision. So we call it is perfectly elastic collision. Otherwise, this is inelastic collision. In this case, kinetic energy means the sum of kinetic energy before is not equal to sum of kinetic energies after. As in this case, sum of kinetic energy before is not equal to sum of kinetic energies after collision, so it means that this is inelastic collision. Because sum of kinetic energy before collisions is equal to 53 and this one is greater than 38, means sum of kinetic energies after collision. So it simply means that this collision is inelastic. So this is you need to state, you have to write down inelastic. And this question has 2 marks. One 1 mark you will get, that is the C mark, if you have got right value of initial kinetic energy and you have also got right value of final kinetic energy. Then you will get 1 mark, and that is C mark. And you will get second mark, that is answer mark, if you have written this collision is inelastic. So this is how marks will be awarded for this question. For our question number 5, it is given to us light from a laser is used to produce an interference pattern on a screen as shown in figure 5.1. Interference pattern means that you will see bright and dark fringes on the screen, and that is called interference pattern. As you can see here, at the center we have center bright fringe, then we have dark fringe, then we have bright fringe, and then we have dark fringe. And this pattern is called interference pattern. For this question, separation between two slits is also given. That is equal to 0.44. Mean this is the distance from the center of one slit to the center of another slit. We can use letter A for slit separation. Distance between screen and slits is also given. That is equal to 1.8, and we can use letter capital D for this one. Fringe spacing. Fringe spacing, we need to understand this is the distance between two consecutive right fringes, and we can use letter X for fringe spacing. Wavelength of incident light is also given. That is equal to 660 nanometers. For part A, it is given to us light waves from the two slits are coherent. We need to state what is meant by coherent. And this question has only 1 mark. First of all, let's try to understand what does it mean by coherent. So when we say two light waves are coherent, it means that those two light waves, they have constant phase difference. So we can simply write down, if two waves, they have constant phase difference, we call them, they are coherent. And that is only possible if waves, they have the same frequency. So we can write down same frequency. If the waves, they have same frequency, it means those waves can be coherent. Mean the phase difference can be constant. So let's try to understand what does it mean by coherent. Constant phase difference. So if you look at two waves, you can see this wave is red wave and this one is blue wave. If you look at any point, they have constant phase difference. You can also imagine that like this. We have these two waves. One has crest, one has trough. So always they are like this. Mean at any point you will see the phase difference is equal to 180 degrees. So it means that they have constant phase difference. So we can say these two waves, they are coherent. Now imagine that we have two waves like this. So if they move all the time like this, if they have the same frequency, they will be coherent. So they will have constant phase difference. Or you can imagine that we have two waves like this. So they have the constant phase difference all the time. So we call them coherent waves. So if you look at this figure, you can see red and blue. At any point, if you find out the phase difference is equal to 180 degrees. So these two waves, they are coherent. So coherent simply means that two waves, they have constant phase difference. Means the phase difference does not change with time. And that is only possible if they have same frequency. Now let's try to write down how we can write down the answer. So for coherent, simply you can say waves are coherent if they have constant phase difference. You can say waves are coherent if they have constant phase difference. So we can say waves are coherent. So simply you need to write down, if waves, they have constant phase difference, they are coherent. So for 1 mark, if you write down this one, you will get 1 mark. Or simply you can say constant phase difference between the waves. If you want to write down in a proper way, between the waves. So that's all what you need to write down for the answer of this question. For part B, it is given to us for the two light waves superposing at capital R, means superposing at this point where they form the dark fringe. We need to calculate difference in the path, means we need to calculate path difference in nanometers from the slits. It simply means that we have two waves. One wave is coming from here and that wave reach at this point. Another wave we can use different color and we can draw from this slit, and this wave is also reaching at this point. We need to find out the path difference, means the difference in the distance traveled by blue wave and red wave. So that difference we need to find out. We can also draw the normal line here. So this one is the normal line we can draw here. So this is the path difference. So you see, travel this much distance more than the red one, and that one we need to find out. Now first of all, we need to understand path difference between, for example, at this point we have n is equal to 0. It means that path difference is equal to 0 when the waves reach at this point O and they form the bright fringe. And if you look at point Q, at point Q n is equal to 1. It means that the path difference between two waves reaching at this point is equal to 1 lambda, and this one is equal to path difference between these two waves, PD, we can simply say, has to be equal to 1.5 times lambda, because at this point path difference is equal to 1 lambda, and at next dark fringe path difference will be equal to 1.5 lambda. So simply in this case path difference PD is equal to 1.5 times lambda. Simply we can say wavelength. So this is 1.5 times 660 nanometers. If we multiply this one, our final answer will be 990 nanometers. So simply we need to write down here 990 nanometers. This question has only 1 mark. If our answer is right, you will get this mark. For the next part, we need to calculate phase difference. Now phase difference again between two waves when they superpose at capital R, we need to calculate phase difference. So one thing we need to understand, the phase difference, dark fringe is formed. It means the phase difference is equal to 180 degrees. Let's try to understand this one in a little bit different way. We need to understand phase difference. So I will be writing here the phase difference. Simply we can understand this one with the help of formula. Phase difference divided by 360 degrees. This one has to be equal to path difference. So I can simply write down this one has to be equal to path difference divided by lambda. Now for this question, we need to calculate phase difference. So I will be writing here phase difference. So this is what we need to calculate. Phase difference in this case will be equal to path difference. So this is path difference multiplied by 360 degrees, and this one has to be divided by lambda. Now from here we can say path difference is equal to 1.5 times lambda, and this is divided by lambda and multiplied by 360 degrees. So this lambda we can cancel with this lambda. Now 360 degrees you need to multiply with 1.5. So our final answer in this case will be equal to 540 degrees. So the phase difference is 540 degrees. This formula is very important. You can see in this formula how phase difference and path difference, they are linked together. So the understanding of this formula is very important, and you will see this type of questions in many past papers. So try to understand this concept, how these two, they are linked together. So in this case, phase difference is equal to 540 degrees. So we can also understand this one in a little bit different way. For example, the phase difference here will be 0. Phase difference here will be equal to 360, and phase difference here, next dark fringe, so the phase difference will be equal to 360 degrees plus 180 180 degrees, and this one will be equal to 540 degrees. You can also simply calculate like this. So this is another way to calculate phase difference. So n is equal to 0, it means phase difference is equal to 0. N is equal to 1, phase difference is equal to 360 degrees. So the next one 1.5, so next one will be 360 plus 180. So this is how you can calculate. For part C, we need to calculate the distance OQ. It simply means that we need to find the fringe spacing between the center bright fringe and the first bright fringe, means the first order bright fringe. Let's say fringe spacing is equal to x, and the slit separation is equal to a, and the distance between slits and screen, let's say that distance is equal to capital D. Now we need to understand how these quantities are linked together. So simply this is Young's double slit experiment equation. According to Young's double slit experiment equation, Ax is equal to lambda times T. In this case, we need to find out x, so we can simply write down this is equal to lambda times capital D divided by A. Lambda is given, that was equal to 660 nanometers, so we need to convert this one into meters. So you need to be careful with units. So this is value of lambda. D is given in meters, so simply we can write down this is 1.8 meters, and slit separation is given, that is 0.44 millimeters. So we have to convert this one into meters. Now simply if we put these numbers into calculator, we can find out value of x, means we can find out fringe spacing. That one will be equal to 2.7 times 10 to minus 3 m, means 10 to minus 3 meters. So this is our final answer, and this is the fringe spacing. X is called fringe spacing. So simply you have to use formula for this question. Fringe spacing between two consecutive bright fringes. Spacing between two consecutive bright fringes. This question has 3 marks. The first mark you will get, that is C mark, if you have used this formula, if you have written this formula. And the second mark you will get if you have plug in values, mean if you have sub in values. And the third mark is the answer mark. If you have got the right answer, you will get a mark. So this is how marks will be awarded for this question. For part D, it is given to us the intensity of the light incident on the double slit is increased without changing the frequency. Describe how the appearance of the fringes after this change is different from and similar to their appearance before the change. Let's try to understand what is happening in this case. First thing you need to understand, we can say the first case. I will simply write out here case 1. In case 1, let's say we have intensity of the light is this. So this is intensity, the amplitude of the wave. So two waves, when they meet at one point, they will form bright fringe or they will form dark fringe. So first of all, we will take these two waves. So the intensity amplitude is this one. So these two waves. So when these two waves, first of all, let's say they are in phase and they meet at one point. So we can write down in phase and they meet at one point. They superpose when they are in phase. So when they will superpose at one point and they're in phase, we will see a super crest. So this is what we will see, super crest. And when they're anti-phase, they will form the dark fringe when they're anti-phase. So this is in phase, so in this case you will see a bright fringe. So this is what is happening in the first case, bright fringe. That when these two waves, they are anti-phase, mean one wave is this and the other one is this one, and they superpose. These two waves, they will cancel each other and we will see no light. So simply what we will see this one, and this is what we are saying is dark fringe. So this one is dark fringe. Now the second case, when the intensity has been increased. So the first thing we need to understand, intensity is linked with amplitude of the wave, amplitude square. Now we can write down, we have two waves, but the amplitude is greater than before. So let's say the amplitude is greater than before. And when these two waves, they will meet at one point, means they are in phase and they meet at one point, we will see a super crest. So I can draw here. In this case, you will see a super crest. You see the intensity of the bright fringe has been increased. So simply in this case, bright fringe will be brighter than before. So we will write down bright fringe will be brighter than before because its amplitude is greater. So the bright fringe will be brighter. Now, if you look at these two waves, when they meet and they cancel each other, mean they are in antiphase. So again, we can draw. So we have one wave, it has higher intensity, and we have another wave. This one also has higher intensity. So we can draw this bit. Again, they have the same amplitude. And so this has positive amplitude, this has negative. So when these two waves, they will meet, they will cancel each other. So we will simply see this dark fringe. So in this case, there will be no change in dark fringe, but there will be change in bright fringe. Means the bright fringes in this case, they will be brighter, and the dark fringes, they will stay same. We will see no light. Dark fringe, no change. So we can simply say they will stay same. There will be no change. And also we need to understand, if you look at the formula, the second thing you can understand is, if you look at x, we have discussed that Ax is equal to lambda times t. So we can say x is equal to lambda times capital T divided by A. We are not changing A, so A stay constant. We are not changing D, D stay constant. Frequency is the same. It's telling us same frequency. So it means lambda is also the same. So it means x also stays same. So fringe spacing is same. In this case, we can say bright fringes, you can write down. This question has 3 marks. So first point you can write down. Bright fringes get brighter. So they're brighter than before. Get brighter, or you can simply say bright fringes are brighter than before. 1 point you can say. And the second point you can say no change in dark fringes. No change in dark fringes. So this can be the second point, no change in dark fringes. Again, they completely cancel each other. So no light, we don't see any light. Then the third point we can say fringe spacing is the same. As x is same, you can say fringe spacing same. So fringe spacing same. That's all what you can write down for this question. Or you can simply say no change in fringe spacing. Or you can say fringe spacing stays same. For part E, it is given to us the light of wavelength 660 nanometer is now replaced by blue light from a laser. State and explain the change, if any, that must be made to the separation of the slits so that the fringe separation on the screen is the same as it was for light of wavelength 660 nanometers. First of all, we need to understand the wavelength of blue light. This is shorter than 660 nanometers. So in this case, it simply means that lambda has been decreased. For this question, we need to keep x same. We have to keep fringe spacing same. Means we have to keep x same and we have to keep d same. We have to change slit separation. Now, if we simply look at formula, Ax is equal to lambda times d. We have to keep, in this case, x same. We have to keep, in this case, d same. So we can write down A is equal to lambda d over x. We have to keep d same. We have to keep x same. So if lambda decrease, it simply means that we have to decrease A. Now, let me explain to you how you can write down answer for this question. This question has only 2 marks. For this question, you need to state and you need to explain. So first of all, what you need to state means what kind of change has to be made to the slit separation. So in this case, slit separation decreases. So the statement is that slit separation decreases. So we can write down our statement, slit separation decreases. So this is our statement. And then we need to explain this one. Means we need to write down explanation. We need to explain this one. Our explanation will be as the wavelength of the blue light is shorter than 660 nanometers, is shorter than 660 nanometers. That's the reason slit separation has to decrease. So here we have statement, here we have explanation. This question has 2 marks. The first mark is M mark. If you have written this explanation, you will get 1 M mark. And the second mark is answer mark. If you have written slit separation decreases, you will get answer mark. But in this case, if you simply write down slit separation decreases, you will not get any mark, because you have to get M mark to get A mark. So you have to write down, first of all, wavelength of blue light is shorter than 660 nanometers, so slit separation decreases. So this is how you can answer this question. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on electricity and radioactivity from May-June 2022, paper 2, variant 2. In this lesson, we will discuss some very important points about electricity and radioactivity by solving past paper questions. This video is very important because this video will help you to improve your conceptual understanding of these two topics. Let's study together. Let's improve together. For question number 6, part A, we have a network of resistors as shown in figure 6.1. For this question, we need to show that combined resistance capital R of the network is given by this equation. It's given by this. Simply, we need to find the total resistance. In order to understand this question in a better way, we can also imagine a power supply that is connected across this network, and potential difference across terminals of this power supply, imagine that this is equal to V. Meaning the potential difference across terminals of power supply is equal to potential difference across this network of resistors. And as you can see, this is given to you is V. First thing, now we need to understand the main concept we need to answer this question is when resistors are connected in series. So all the resistors, they will have same value of current, means they have the same current, and they will share voltage. They will share voltage, but they will have same current. Using this concept, we can write down potential difference across power supply will be equal to potential difference across first resistor plus potential difference across second and across third resistor. Now in this case we have current I, so we can write down total current in the battery, means in the circuit, that is I times R is the total resistance. If we need to find out potential difference across terminals of power supply, we can find out by I times capital R. So the potential difference across R1, that one will be equal to I times R1, and potential difference across R2 will be I times R2, and this will be I times R3. In this case, we can take I common. So you can take I common. So if we take I common from here, so we left with R1, R2, and this is R3 here. So simply we can cancel I with I. So we left with total resistance that is equal to R1 plus R2 plus R3. So this is what we need to derive, and this is our final answer. This question has 2 marks. The first mark you will get if you have written V is equal to V1 plus V2 plus V3, and this is B mark, meaning it has to be in your answer. And the last mark is also B mark if you have got the right answer and also you have written this step. You will get the second B mark. This is how marks will be awarded for this question. For part B, it is given to us a battery of electromotive force 8.0 volt and negligible internal resistance is connected to a thermistor, a switch X, and 2 fixed resistors as shown in figure 6.2. Value of R1 is given, that is equal to 6 kilo ohms, and value of R2 is given, that is equal to 4.0 kilo ohms. It is also given to us for part B1, switch X is open. We need to calculate potential difference across R1. So simply what question is asking you to calculate value of V1. So if you connect your voltmeter across R1, what is the reading on this voltmeter? So this is what question is asking us. Now we need to understand, in this case, this is our circuit now. In this case, current will flow like this. Current will pass through this R1, then it will go through R2 and finally come back. So this is our circuit. So this is our circuit. In this case, you can imagine that there is current I. So I is passing through this one and also passing through this, and also the amount of current coming from the battery, that is also I. So these three components, they are connected in series. So it means current is the same. So I can write down current passing through the battery means the I total. I total, I can simply say this one will be equal to potential difference across the battery divided by the total resistance, means R1 plus R2. And if I write down current passing through resistor 1, I can simply say this one is I1. That one will be equal to V1 divided by R1. As they are connected in series, it simply means that I total, this is equal to I1 and this is equal to I. So simply we can use this idea, current is the same. So I total, we can say that this is equal to 8.0 divided by, we have 6 plus 4 kilo ohms resistors. So this is 10 to 3. And for V1 we need to find out. So the R1 we have, that is equal to 6 times 10 to 3 ohms. We need to find V1. So V1 simply we can find out, that will be equal to 8.0 times 6 times 10 to 3 divided by 6 plus 4, this is 10 times 10 to 3 here. So we can cancel this with this one. So 8 times 6, 48, and divided by 10, this one will be equal to 4.8. So the value of V is 4.8 volts. So our final answer for this one is 4.8 volts. Otherwise, I can simply use this formula. If I need to calculate V1, I will say resistance of R1 divided by R total multiply with battery potential difference. Or you can say, in this case, this is R1 divided by R1 plus R2 multiplied by V. So this is how you can calculate V. This is. But I have explained you in detail how we got this formula. This question has 2 marks. The first mark you will get if you have used this relationship. So C mark. And if you got the right answer, you will get second mark, that is answer mark. For the second part, it is given to us switch X is now closed. The resistance of the thermistor is 12.0 kilo ohms. We need to calculate current in the battery. Means we need to calculate total current in the circuit. If you look at our circuit now, the circuit is like this. So we have 3 resistors in this circuit. Resistance of thermistor is given, that is equal to 12.0 kilo ohms. And we can imagine that, or simply you can assume that the total resistance of these 2 resistors, let's say that is equal to R prime. We need to find the total resistance of 2 resistors in parallel. So simply we can say that one will be equal to R2 times Rx, means resistance of thermistor, and we need to divide this one by R2 plus Rx. So now we can plug in values and we can find out value of R prime. R2 is 4 kilo ohms and Rx is 12 kilo ohms. We need to divide by sum of these two. So we have 4 plus 12 times 10 to 3 here. So 10 to 3 we can cancel. If we multiply 12 with 4, we will get 48. And 12 plus 4 is 16. So if we divide 48 by 16, we will get 3.0 times 10 to 3. Simply you can say this is 3 kilo ohms. So the combined resistance of thermistor and R2 is equal to 3 kilo ohms. Now we can redraw our circuit. For better understanding, we can redraw this one. So we have power supply. So this is battery. So this is our power supply. And we have one resistor R1 that is connected here. Then we have another resistor, the combined resistor of thermistor and R2, that one is R prime, and the resistance of this one is 3.0 kilo ohms, and the resistance of R1 is 6.0 kilo ohms. Battery potential difference is given, that is 8 volt. We need to find current in the circuit. Let's try to find out current in the battery, or simply we can say total current in the circuit. So we can write down I total. This will be equal to EMF of power supply, or simply you can say potential difference across terminals of battery, because this battery has no internal resistance. So simply we can say we have 8 volts. This is EMF of power supply, and the total resistance is 3 plus 6 times 10 to 3. Now if we solve this one, our final answer will be 8.9 times 10 to negative 4 amps, and this is our final answer for this question. I mean, this is the current coming out of battery, or this is the current in the battery. So our final answer is 8.9 times 10 to negative 4. This question has 2 marks. The first mark you will get if you have got right value of R prime, and this is C mark. And the second mark is answer mark. If you have got right value of current, you will get the second mark. This is how marks will be awarded for this question. For part C, it is given to us the switch X in the circuit in B remains closed. The temperature of the thermistor decreases. By reference to current in the battery, mean in our answer we need to talk about current in the battery. We need to state and explain the effect, if any, of the decrease in temperature on the power produced by the battery. So we need to explain effect on power produced by the battery, and also we need to talk about current in the battery in our answer. First of all, let's try to understand a little bit about thermistor. For thermistor, you need to understand, if we decrease temperature of the thermistor, its resistance increases, and vice versa is also true. If you look at thermistor curve, simply you can understand from thermistor curve, we have resistance, let's say, on y-axis, and we have temperature on x-axis. In this case, you will see the curve is somewhat like this. So this curve is like this. In this case, you can see when temperature is low means when thermistor is cold, resistance is high. So simply we can say resistance is high at this point. If you look at this point, temperature is high but resistance is low, means when thermistor is hot, resistance is low. So this is the point you need to understand. Now in this case, temperature decrease, so resistance of this resistor means the thermistor increase. So this resistance increase. Now let's try to understand the effect of increase in resistance on this total resistance. In the previous part, we have calculated R prime. We said the total resistance of these two resistors is R prime, and that was equal to 3.0 kilo ohms. Now imagine that this resistance, this has increased. So how about R? So we can simply find out from here. Let's say this resistance become 100 kilo ohms. 100 kilo ohms. So we can calculate total resistance. So this is 4 times 10 to 3, and here we have 100 times 10 to 3 divided by, we have 4 plus 100. I choose this big number to show you the difference, times 10 to 3 here. So this one you can cancel with this. So we left with 4 times 10 to 3 times 100, and this is 104. In this case, you can see here we have 400 times 10 to 3, and this is divided by 104. So simply we can imagine this is 100. So if you solve this one, your answer will be about 4 kilo ohms. So simply you can see from here, if this resistance increase, total resistance of these two resistors increases. So this is the main concept we need to understand. Now let's try to understand what is the effect on R total, means total resistance of the circuit. So total resistance of the circuit is R1 plus R prime. So this is R1 plus R prime. So if R prime increase, this remains constant. So it means R total increases. So if R total increase, we can calculate total current in the battery. So we can say I total. This will be equal to V over R total. So we have R total. If R total increase, EMF of the power supply remains constant. It means I total current in the battery, this one will decrease. If current in the battery decrease, how about power produced by the battery? Power produced by the battery is equal to EMF of the power supply times I. So if I decrease, EMF of the power supply remains constant, so it means power produced by the battery decreases. So this question has 3 marks. So the first mark we can say the first point you can write down as temperature decrease, resistance increases. And the second thing we can say total resistance, this one increases. And third point you can say current in the battery decreases. And the last one we can say power produced decreases. So these 4 points we can mention and you will get 3 marks. Let me show you now how you can write down your final answer. In your final answer you can mention these points. So if you mention the first point, you will get 1 mark, and that is B mark. Means if you have mentioned thermistor resistance increases as temperature decreases, you will get 1 mark, and that is B mark. Then the second mark is M mark. If you have mentioned total resistance of circuit increases due to increase in thermistor resistance, so current in the battery decreases. If you have mentioned these points, you will get 1 mark, and that is M mark. And the last mark is if you have mentioned power decreases, and this is answer mark. So the M mark is must mark. You must get M mark to get A mark. Even if you have written power produced by battery decreases, but this point is wrong, you will not get any mark. So you need to get M mark to get A mark. For question number 7, part A, a nucleus of cesium-137 decays by emitting a beta minus particle to produce a nucleus of an element X and an anti-neutrino. The decay is represented by this equation. We need to state the number represented by each of the following letters. So let's rewrite this one. So first of all, we have cesium-137. So the atomic number is 55 and the mass number is 137. Then we have element X. So this is element X. We don't know about this element. And then is beta minus decay. So we have beta minus decay. So it means this has to be -1, this has to be 0. And next one we have anti-neutrino. So this one is anti. This is electron anti-neutrino. So this is electron anti-neutrino. Now we need to find out this number. Means the atomic number of X. We need to find out mass number of X. Now in this case, simply you need to understand we have 55 here and -1. This one is -1. So this one plus this one has to be equal to 55. So this has to be 56. So we have 55 on left side and we have 56 -1, 55 on right side as well. Now we need to understand mass number. So you can see on left side we have 137, on right side we have 00, so this one has to be 137. Now for P, this is P, so we can say P is equal to 0, and then we have R, so this one is R and this one is P. So the R is equal to -1 and we have Q. Q is equal to 137 and S is equal to 56. So this is what we need to do for A1. Now for A2 we need to state the name of the group of particles that includes beta minus particle and anti-neutrino. Means these two particles, particle and antiparticle, they belong to one group. We have to write the name of that. And these particles, they belong to to lepton family. So simply we have to write out here leptons, because electron, muon, and tau and their neutrinos, they belong to lepton family. So simply we can say they belong to lepton family. So they are leptons. That's all what we need to write down for this question. Now simply we can also write on here leptons. For part B, it is given to us a particle Y as a quark composition of DDD, and D represents a down quark, and Z particle as a quark composition of up antiquark and down quark. It is also given to us U bar represents an up antiquark. We need to show that charges of particles Y and Z are equal. So first of all, we can find out charge on particle Y. So we can write down charge on Y. In order to find charge on Y, we can write down composition of Y. Y consists of 3 down quarks. Then the charge on one down quark is minus 1 over 3e. So we need to add this one, or simply we can multiply this one by 3 because they have the same charge. So in this case, we will get minus 1e. So this is the charge on Y. We can also find out charge on C. Charge on C. Quark composition of Z is, it consists of 1 up antiquark and 1 down quark. Now we need to understand charge on up quark. Charge on up quark is 2 by 3e, but this is up antiquark, so this has to be opposite charge, mean this is negative, and down quark has charge negative 1 over 3e. Now if we simply add these two together, our final answer will be negative 1e. So in this case, you can see charge on Y is equal to charge on C. That's all what we need to do for this question. You will get 1 B mark if you have written the charge on Y, and the second B mark you will get if you have written the charge on C. For the second part, we need to state and explain which particle is a meson and which particle is a baryon. We have two particles. We have particle Y, and quark composition of this particle is here. It consists of 3 quarks. As it consists of 3 quarks, so this one is baryon. So simply we can say Y is baryon because it consists of 3 quarks. If you look at quark composition of Z, it consists of 1 quark and 1 anti-quark. And this one is meson because meson consists of 1 quark and 1 anti-quark. So this one is meson. In our answer, first of all, we need to write down meson. So Z is meson because it consists of quark and anti-quark. It consists of 1 quark and 1 anti-quark. 1 quark and 1 anti-quark. Any particle which consists of 1 quark and 1 anti-quark, that particle belongs to meson family. Y is baryon because it consists of 3 quarks. So any particle which consists of 3 quarks, that is baryon. If it consists of 3 anti-quarks, that one will be anti-baryon. This question has 2 marks. The first mark you will get if you have written meson, means Z is a meson, and then you have explained what is meson. Then the second B mark you will get if you have written Y is a baryon and you have explained what is a baryon. That's all what we need to do for this question. And that's all for today's class and also for this paper.